Welcome back to our channel. As we discussed, today we are going to discuss about the compliance curve, and in previous video itself at the beginning I told compliance is more during expiration, less during inspiration. So, I am going to discuss all that today and what is the cause of hysteresis loop. Hysteresis loop is nothing but the difference between the compliance during inspiration curve and the compliance during expiration curve. Okay, we will go one by one. This is what I have given is intrapleural pressure. So, we all know compliance is the change in volume for a given change in pressure. If I am going to discuss lung, this should be transpulmonary pressure. So, for the change in transpulmonary pressure, how much volume the lung expands, that is called compliance. Since I want to make the numbers easy, I have put it as intrapleural pressure. Just here at rest intrapleural pressure is -5, at rest alveolar pressure is 0, intrapleural pressure is always negative even at rest, which is -5. So, if I put transpulmonary pressure, it will be +5, 0 minus -5 +5, -6 I have to calculate, -8 at the end of maximum inspiration. So, it will be around +7. So, since I want to make it easy, I put -5, -6, -7, -8 intrapleural pressure, that is. If I want to put the exact value of transpulmonary pressure, I have to calculate. This is +5 at the start of inspiration. At the end of inspiration, it is +7. So, how much is change? +2. So, for inspiration, just here, this is the compliance curve. The x-axis is change in pressure, y-axis is change in volume. For compliance of lung, what I am drawing the curve is compliance of lung. So, for compliance of lung, the change in pressure is transpulmonary pressure, the pressure difference between alveoli and intrapleural pressure, or the pressure difference across two structures, alveoli and pleura. So, during this inspiration, the change in pressure is +2. For this +2, how much? Approximately 500 ml tidal volume. So, I have discussed the volume pressure relation. That is why compliance curve is also called as pressure volume curve. We call it as pressure volume curve. So, now I want everyone to concentrate just to see here. If I see this, now I am going to explain only about inspiration. So, inspiration curve has 3 parts. Just concentrate. First part, second part, third part. Just I want to listen, just to see here inspiration, compliance during inspiration. At the starting stage, I require more pressure because it is flat tube, it is almost like flat. Then steep rise, then again plateau or flat pace. So, what I want to say is the compliance curve during inspiration is almost like 3 phases. Yes, here the pressure is changing, but the volume change is almost straight line. If it is going like this, volume change is less. If it is going like this, volume is increasing. So, here even for some increase in pressure, the volume is not changing that much. Then in the middle of the compliance curve, the volume change is there. It is almost directly proportional. As the pressure changes, more volume. Then again it is going for plateau pace. Pressure is changing, but volume change is not that much. So, 3 phases of compliance curve. Starting, more pressure is required. Then as the pressure increases, volume increases. Again towards the end of inspiration, I require more pressure. So, that is what I am explaining. Now, we can causes. So, you have to imagine balloon. I would blow it now I am not having. Just imagine inflation of lung is similar to blowing a balloon. So, now imagine I am blowing a balloon. Initially, I have to blow some air into the balloon so that it is inflated. I will take some time because imagine the balloon is now without any air. So, I am not, it is deflated. Imagine the deflated balloon. When I am blowing, initially I have to inflate, some air has to enter in, then only it will start blowing. So, that is this phase. Do not write this balloon and all, for understanding I am telling. So, this phase is initial inflation. So, more pressure is required. Then once the balloon starts inflates, so already that initial resistance I have removed by inflating. The first phase is over. I am giving some inflation, and the pressure is taken. See here, some steep pressure is taken. So this flat phase is over. I am inflating the balloon. Now already the required pressure is achieved and the balloon is inflated, the lung is inflated. Now it is very easy. So this is blowing the balloon. So this is blowing of balloon or inflation of lung. This is initial difficulty and now it is overinflated. This phase, why the phase 3? Again the plateau phase. I require more pressure. This, imagine now the balloon is full. Now if you again give more pressure, the balloon may burst out. So you imagine once the balloon is full, even if you blow, the inflation is going to be very less because already it is inflated. So here almost the pressure is almost nearing and almost the volume has reached 400 ml. I can't give more pressure now. So the first phase is, I have another thing in the first phase, I have to overcome the elastic resistance. So require more pressure. Hence flat phase. Second phase, already that elastic resistance I have overcome by giving some pressure, and elasticity I have fighted with elasticity. We all know compliance, elastance opposite each other. I have fighted with that elastance. Then I am able to blow. So smooth or steep rise, second phase. Third phase, already the balloon is inflated and I require more pressure to inflate that little bit because I have to be very careful. So I can't overextend. That's what, I can't over inflate. So it is a precaution, safety measure. That's the reason for the 3 phases of the compliance curve during inspiration. Just concentrate. So this is the compliance curve during inspiration, which has 3 phases. We finished that explanation. This is expiration. Listen here, the compliance during inspiration, as the pressure changes, as the transpulmonary pressure changes, the lung enlarges, inspiration. Again as the pressure changes, the lung expires. This is expiration. What we expect, it should be same. The compliance during inspiration, expiration should be same, but it is not the same as previous video. Compliance is more during expiration. You can see clearly. Just concentrate, or I will even draw. Now imagine I take the pressure of, this is intrapleural pressure, -6. Just to concentrate this diagram, compliance curve diagram. For change of certain pressure, the volume change is 100 ml, but in the expiration curve, the volume change is almost 300 ml. So the pressure is same, -6. So the del P, the change in pressure is same, but the volume change is more during inspiration or expiration. Yeah, the volume change is more during expiration, approximately 250 or 300 ml for this -6, but here it is only 100 ml. So approximately I am telling. So the compliance curve is more during expiration. For the expiration curve, the pressure change required is very, very less, but the volume coming out is more. For inspiration, the pressure change required is more, but the volume inflated is less. So compliance curve is more during expiration, and this gap is called, hysteresis. Since it is like a loop, you will call it as hysteresis loop. So what is hysteresis loop in compliance curve? The gap between the compliance curve during inspiration and expiration is called hysteresis loop. What is this gap? Compliance during expiration is more, it is shifted to left side. Compliance during inspiration is right side. Right side means more pressure is needed. Left side means less pressure. For example, for change of 100 ml, I require -6 pressure. For change of 300 ml in expiration, I require the same pressure. So the pressure required is less for more volume. That's why compliance is more during expiration. Note it down. If you want the pulmonary pressure value, you can think, just I will write inspiration, expiration. Yeah. Alveolar pressure during inspiration, at the start of inspiration it is -1, expiration is +1. Intrapleural pressure, you can put rest also, so that you will understand. Just concentrate, rest, inspiration, expiration. At rest, alveolar pressure is 0. At the start of inspiration it is -1, so air is coming in. When we are going to expire, the alveolar pressure is +1. Intrapleural pressure at rest it is -5. We all know intrapleural pressure is always negative. At the start of inspiration it is -8. For expiration it is -5. So transpulmonary pressure it is +5 at rest. For inspiration it is -1 minus -8 +7 +6. So even if we calculate, we can clearly see for inspiration the change in pressure record is +5 to +7 +2. For expiration the change record is +1. So though I am deviating from the compliance curve, which is worth knowing the values also. So you can clearly understand. Again repeat, see here, at rest I am not inspiring, not expiring. My alveolar pressure is 0 because no air is coming into the alveoli, no air is going out of the alveoli. When I inspire, my alveolar pressure is -1. So outside it is 760, inside it is 759. So the air comes inside. Expiration, inside is 761, outside is 760. So air goes out, +1. Intrapleural pressure at rest -5. Intrapleural pressure is always negative. Please watch my mechanics of respiration video. Inspiration, the pleural pressure becomes more negative, so the lungs expand, so that the air comes in, -8. Expiration, it is -5. So even when I put the values, what I want you to note down is +2 pressure is required for inspiration. +1 pressure, that is transpulmonary pressure. Transpulmonary pressure is the pressure for which volume change in the lung occurs. That's what I actually have to put in this. But for understanding sake, -5, -6, -7, -8, I put intrapleural pressure. You can put intrapleural pressure, or if you want to put, you put transpulmonary pressure +5, +7, like that you can calculate. Yeah, +2 transpulmonary pressure is required for inspiration of 500 ml. +1 pressure is required for expiration. So tell me, which is more compliant, inspiration or expiration? Where the pressure record is less, expiration. So volume change is going to be same only, 500 ml, but the pressure record is less. What is compliance formula? Del V by del P. So del P is +1 for expiration, del P is +2 for inspiration. So compliance is more during expiration. Very, very simple. Cause for this hysteresis. Yes, concentrate. I am going to draw alveoli. Normal alveoli, expanded alveoli, fluid. Alveoli has alveolar fluid or air fluid surface, Just concentrate here. Normal alveoli at rest. When I inspire, the alveoli expands, no doubt in that. And we all know alveoli has air fluid surface, which is responsible for surface tension, and surface tension decreases compliance. We all know alveoli is lined with surfactant. Is surfactant. You can even pause the video and try to answer. Can you explain what is the difference between surfactant present in resting alveoli, surfactant present in expanded alveoli? This is alveoli after expiration. After expiration, alveoli still becomes smaller. Yes. Now see here, normal alveoli, expanded alveoli. After expiration, the alveoli size decreases. Now tell me what happens to the surfactant. Just the question is, if you tell this answer, we know the reason for the difference between compliance during inspiration and expiration. Yeah, normal alveoli, concentration surfactant. Yeah, see here. Once you expire, the alveoli size decreases. As size decreases, concentration of surfactant increases. Please note it down. So as size decreases, the concentration of surfactant increases, almost like coming towards each other. They are very close to each other. That means concentration is more. When I inspire, imagine balloon. Imagine I am putting 8 surfactant into the balloon. When the balloon is small, that 8 surfactants are close to each other. When I blow the balloon, this balloon becomes like this, but the 8 surfactant, what will happen to the 8 surfactant? It will be in this one corner, that corner, this corner, because balloon is big. The same thing, as the alveoli expand during inspiration, the surfactant away from each other. This concentration, note it down. As the alveoli expands, surfactant concentration decreases. What is the function of surfactant? Surfactant reduces the surface tension caused due to air fluid interface. During competence curve, during inspiration, what happens to the surfactant concentration? Inspiration. When I inspire, alveoli size becomes big. As I told the balloon example, surfactants are distant. See the gap between each surfactant. So concentration of surfactant decreases. Compliance will decrease. During expiration, when I expire out, alveoli size is reduced. What happens to the surfactant? Surfactant concentration is increased. So what surfactant function? Decreases the surface tension and the compliance is increased. So compliance is increased during expiration, decreased during inspiration. This difference is called hysteresis slope, but it is not over. One of the cause for hysteresis is surfactant. Now coming to second cause, we all know lungs have elastic nature. Lungs are composed of elastin, collagen. It is elastic in nature. If I take lung from my respiratory system, keep it outside, it loves to recoil. Note it down. Recoiling and elastic capacity of lung is very well known. And when I inspire, I have to overcome that elastic resistance. Initially also we saw here, this phase, I didn't mention that I think, to overcome the elastance initially. So that to overcome the elastance, that also could be the reason for requiring more pressure, and the starting stage, the curve is flat. So one is surfactant. Another reason is inspiration. I have to overcome the elastic or elastance of lung. Elastance is recoiling. Lungs love to recoil. Against that, I have to overcome. Against that, balloon loves to recoil. Against that, I have to blow the balloon. But for expiration, I am going to do what the lung loves. Lung wants to recoil. I am also going to recoil by breathing out. Simple. Expiration helping the elasticity. Again, very important point. Inspiration, I have to overcome the elastic nature of the lung and inspire and expand the alveoli. When I expire, already lung loves to recoil and I am helping it to recoil. So this is like active. This is like passive. Inspiration is active process. Expiration is passive process. So that is also one of the reason for the difference between compliance during inspiration and the compliance during expiration. Another concept I am going to discuss, or you tell me, instead of lung with air, I am filling it with saline. So no air, I am just filling the lung with saline. What will happen to the compliance? Please try to answer. The compliance is increased or decreased or same? Yes, the answer is compliance is increased. So I will draw it here. So just to concentrate here, this is saline and this is air. So shift to left, that means pressure required is less but volume change is more. Shift to right means pressure required is more for change in volume. So here the compliance is increased. So note it down. When I fill the lung with saline, the question will be asked, lung, you know all, we are filling it with air by inspiring and expelling the air. When I am filling the lung with saline, experiment, I am filling the lung with saline, what happens to the compliance of that saline-filled lung? The answer is compliance is increased. See, if I cannot draw here. If I draw here means compliance is decreased, more pressure is required. Now tell me why. You can answer very easy. Why the compliance of saline-filled lung is more than air-filled lung? Very simple. No air. Just to see here. I will draw here. No air. Saline is fluid. What is the reason for surface tension? In the alveoli, it is because of air-fluid interface. Air-fluid interface. Only when the air and fluid are there, there is a surface tension. At the surface of the alveoli, fluid is lined. When air comes, air is different medium, fluid is different medium. Air-fluid interface. Air-fluid interface is responsible for surface tension. But here, surface of the lung is fluid, okay, accept. I am filling it with fluid. Saline is a fluid. So there is no air at all. No air fluid. No air fluid interface, no surface tension. When surface tension is less or no surface tension, compliance is increased. So now I discussed that also. So far in this video I have discussed the compliance curve, which is pressure volume curve, the three phases during inspiration. Compliance curve, flat, steep rise, flat, three phases that we discussed. Then second we discussed why the compliance is more during expiration. This year for the same pressure the change in volume during inspiration is less, only 100 ml, but for the same pressure the change in volume during expiration is more. This difference is called hysteresis. I am going to ask you some questions. I am taking the emphysema, it should be coming here or here. I should draw the compliance curve this side, right side or left side. Yeah, you know emphysema, last class we discussed compliance is increased in emphysema because in emphysema elastic nature is lost. Elasticity is lost, compliance is opposite to elasticity, compliance increases. So what will happen to the curve? So this may be emphysema. So in emphysema compliance is increased. It is not normal, but the volume change is more for a little pressure. Emphysema elasticity is lost. Yeah, fibrosis second. In fibrosis the lung is stiff, elasticity is more. So it is resisting the expansion. That is the nature of lung elasticity. Fibrosis, it is more stiff, like restrictive lung disease. So what will happen to the curve? It will go this side. Fibrosis or compliance is decreased. So in today's video, three phases of compliance curve during inspiration: flat phase, steep rise phase, again flat phase. The reason we explained superbly with balloon experiment. Then why the compliance is more during expiration, the cause for hysteresis we explained in detail. Then what happens to the compliance in fibrosis, emphysema. Then when I fill the lung with saline, what happens to the compliance? As I told, next video will be on surfactant. What is the composition of surfactant, functions of surfactant, how it reduces the surface tension. So all those things we will see in next video. If you have not subscribed to our channel, subscribe to our channel. Physiology lectures by Dr. Sendil Kumar. Happy learning.